in Getting Ready 37 here, our first problem is we have a little scenario about Jasmine headed to a picnic, and we're going to write two inequalities, so a system of inequalities, and then graph that in order to come up with a couple of solutions. So again, as you read through this scenario, when you know you're writing a system of either equations or inequalities, you need to think about what are the two categories of information they're giving me. For example, in this one, they're giving me information about the money, the cost of each type of salad, and how much she is willing to spend. For the other set of information, they've also told me how many pounds of salads she's going to purchase or she wants to have. So my two inequalities, one is going to be about the money information, and one is going to be about the amount in pounds that she is going to provide. The let statement's already done for us to take that confusion out. X is going to represent the pounds of fruit salad. So I'm going to go ahead over here and label that on my x-axis. And Y is representing pounds of potato salad, yum yum. Okay, stick a little title on my graph here. All right, so what do we know about this money? Well, we know each pound of fruit salad costs $2, and she wants to buy X pounds of fruit salad. So she spends 2 times X, 2X, on fruit salad. She's also going to spend some money on potato salad. Potato salad's $4 a pound, so we add on $4 for every pound, and that's Y, of potato salad. Now, she does not want to spend more than 20. Does not want to spend more than 20. That means she's willing to spend 20. It can equal 20. But if not, then she'd prefer it to be under. She does not want to go over $20. So the amount that Jasmine spends has to stay under or exactly 20. Okay, what about the amount of salads that she wants to take? She wants at least 6 pounds. Now this is usually the one that people struggle with more because they feel like they need more numbers. That when I write down the X and the Y, they need to have coefficients sitting in front of them. So what they'll do is often people will try to still write 2X and 4Y in the other inequality also, and they don't belong there. Those are money. So if this inequality is just regarding the amounts of each one, that's what the variables already stand for. X is the amount, the pounds of fruit salad. So the amount of fruit salad plus the amount of potato salad. When I put those together, I want at least 6 pounds. At least means greater than or exactly, greater than or equal to 6. Now, in the past few homework assignments, if you checked out any of those videos, I have suggested with inequalities, solving for Y and graphing with that method. Let's try something a little different here. These are both in standard form. And when we graphed equations in standard form, we said the quickest, easiest way was to identify their intercepts and plot those 2 points. So let's try that with these inequalities. The x-intercept in this pink inequality, x-intercept means you are substituting 0 for y. So this entire 4y term just becomes 0. So it's gone, it's canceled. And I'm left with 2x is 20. So divide both sides by 2, and your x-intercept is 10. For y-intercept, we reverse that and say we're substituting 0 for x. So 2 times 0 is nothing. We have 4y and 20. Divide both sides by 4, your y-intercept is 5. I can fit both of those on my axes without changing my scale. I guess I should actually, before I decide that for sure, I should find x and y intercepts of the other inequality too. So in this blue one here, regarding the amount of salads that Jasmine's going to take, for x-intercept, I replace y with 0, so this term is gone. I have x is 6. For y-intercept, reverse that, replace the x with the 0. Y is 6 again. So yes, I can kind count by ones on both axes and fit all those intercepts. So my money inequality, the x-intercept is 10. So here's 2, 4, 6, 8, 10. And the y-intercept is 5. Here's 2, 4, 6, 8, 10. So 5 would be here. That will be a solid line because this is less than or equal to. And my line will begin and end on the intercepts. I do not extend it into the negatives because X and Y stand for pounds of fruit salad or pounds of potato salad. Those can't be negative amounts. Now, as far as shading, this is the part that is a little bit different if we are using this intercept method of graphing. We cannot trust the inequality symbol in the original inequality. The only time we can trust it is if we are in slope-intercept form. So your choices now are to either go ahead and take this 2x plus 4y less than or equal to 20, solve for y, or what I would prefer to do if this is how you have decided to graph is use that checkpoint method. And what that was is you choose any point on the graph that's not on your line. So I always suggested, if it was possible, if it was off the line, to use 0, 0. 0, 0 is so easy to plug in. So what I'm going to do is take this 2x plus 4y less than or equal to 20, and I'm going to substitute 0 for x and 0 for y to see if that point works. Well, 2 times 0 is 0. 4 times 0 is 0. So I end up with 0 less than or equal to 20. Well, sure, that's true. So what that tells me, since this point down here, 0, 0 worked, it needs to be shaded. Therefore, everything on that lower side of the line, everything underneath the pink line should be shaded. Okay? So everything that I've just made pink, including the line, are possible combinations of fruit salad and potato salad that would cost $20 or less. Okay, that's what the pink section is. Now let's do our blue one, which is about amounts of salads. So both intercepts are 6. So one blue dot on 6 here, one blue dot on 6 here. This line is also going to be a solid line because it's greater than or equal to. We said we wanted at least 6 pounds, meaning 6 would be okay. That would be enough. So solid line from 6 to 6. Again, no negatives. And we can use 0, 0 for our checkpoint again because that blue line also misses the origin. So I go to x plus y greater than or equal to 6, and I substitute 0 for each variable. 0 plus 0 is 0. 0 greater than or equal to 6 is false. So what does that tell me? Well, 0, 0, which is down here under the line, it didn't work. That means it cannot be shaded. Therefore, the other side of the line, so above the blue line, should be shaded. So only above the blue line. Okay, so everything up here. So all of this blue, including the line, represents combinations of fruit salad and potato salad that are more than 6 or more total. So I want 2 possible combinations now of salad that Jasmine could actually buy, that she could afford, and it would provide enough. Well, where we shaded over here, what we're interested in is the overlap part. The section, it's a triangular section down here, that got shaded both pink and blue. So any points in this, what is now a purple section, any of those points should be possibilities for Jasmine. So let's go see what we can find in here. It doesn't matter which points, and they can be on the line. That would be okay. I can tell that 4, 2 is definitely in there. And I can tell that 6, 1 is definitely in there. So one combination would be, since X is fruit salad, 4 pounds fruit salad And the 2 is the y value, that's pounds of potato salad, and 2 pounds tater salad. Another possibility I identified was 6-1, so that would mean 6 pounds fruit salad and 1 pound tater salad. Now, this bottom question here proved that my solutions would fit both constraints. That means you need to substitute these 2 points, 4-2 and 6-1, into both inequalities. So you are actually doing 4 substitution problems. Okay? So when I go to check the point 4-2, that means I need to put it into the pink inequality and show it's less than or equal to 20. So 8 plus 8 less than or equal to 20. 16 less than or equal to 20 is true. And I also need to substitute it into the blue one. So 4 plus 2 greater than or equal to 6. 6 greater than or equal to 6 is true. So I just showed that 4-2 works. Now, checking 6-1 the same way, I will plug it into the pink inequality. 2 times 6 plus 4 times 1 needs to be less than or equal to 20. That's 12 plus 4. So 16 is less than or equal to 20. That's true. And when I substitute it into the second inequality, the blue one, 6 plus 1 greater than or equal to 6, 7 is greater than or equal to 6 is also true. So I showed that that one worked too. All right, number 2, we've got 2 inequalities to graph. They are not in the same form though. One is in standard form and one is sort of almost slope-intercept but not quite. So just to be different from the last one, we'll use this one, we'll use the method where we solve both of these, put them into slope-intercept form, okay? So this first one, x minus y less than -6. I need to isolate the y, so subtract x on both sides, leaving me negative y less than negative x minus 6. Then to get rid of the negative in front of the y, you divide by -1 on every term. So y is, now this is where this method has its drawback, is since we are dividing by a negative, we have to remember to switch the inequality and make it a greater than positive 1x plus 6. The second inequality, I'm only one step from being in slope-intercept form, so I'll just work right here. If I divide everything by 2, I have y is, now this one I don't have to change because I divided by a positive. Y is greater than or equal to 3/2 x plus 17 over 2, or 8.5. Now notice I wrote one of those fractions as a decimal and left the other one in fraction form, and I did that intentionally because as you graph, the y-intercept is easier to locate if it is a decimal. However, the slope is easier to use if it is in a fraction form, so we can think of it as rise over run. Okay. So this blue inequality, I can go to my y-intercept of 6. 1, 2, 3, 4, 5, 6. The slope is 1, so I will rise 1 and run 1. Rise 1, run 1. Rise 1, run 1. It is going to be a dashed line because it is only greater than. It's not or equal to. There's no little bar under the inequality symbol. So let me find my dashed line tool here. And we can trust the inequality in the slope-intercept form. So that inequality, that greater than, tells me to shade everything above this dashed blue line. For the red one, my y-intercept is 8.5. So this one was 6. Here's 7, 8.5. Now, the slope is 3 over 2. So if my rise over run is 3 over 2, and I try to rise 3, I'll be off my grid. So what you can use here is, as long as your slope is as long as it is positive 3 over 2, it doesn't matter how those numbers originate. So we could turn it into negative 3 over negative 2. Negative divided by negative is still the same positive number. So that allows me to say, I'll just go down 1, 2, 3, and left 1, 2. Let's do that again. Down 1, 2, 3, and left 2. 1, 2, 3, left 2. 1, 2, 3, left 2. This one will be a solid line because it has or equal to, greater than or equal to. So a solid red line and again, I can trust the inequality symbol once I am in slope-intercept form. So it says greater than. I'm going to shade above this line. It is important that you then somehow indicate what section is actually your solution to the system. And we know it's wherever the two colors overlapped, the section that was both pink and blue. So it's above the blue and the red. It's this upper section up here. It's not really a triangle. It looks like it from afar, but it would actually make a little quadrilateral. There. Okay, number 3. And these are not in standard form, so I will just be, once again, changing them into slope-intercept form. Let me just start over here. Okay, 4y minus 5x less than 8. To solve for y, I need to add 5x. So 4y is less than 5x plus 8. Divide both sides by 4. Y is less than 5/4 x plus 2. The other inequality, negative 5x greater than or equal to 16 minus 8y. Now, on this one, our y variable is on the, I don't want to say the wrong side, but the side that we're not used to seeing it. So let me talk about 2 ways you could do this. One is, if you want it to be on the left, you can just add 8y to both sides. It's one additional step, and now we're looking at the 8y exactly where we're used to seeing it, on the left-hand side. Finish adding, add 5x, so 8y is greater than or equal to 5x plus 16. Divide everything by 8. So y is greater than or equal to 5/8 x plus 2. Now, if that hadn't occurred to you, or you don't like that idea, we can keep the negative 8y right where it sits. Let's do it that way and see how this comes out. If we are going to solve for y on the right-hand side, then we're subtracting 16. So negative 5x minus 16 is greater than or equal to negative 8y. Divide everything by negative 8. So I have 5/8 x plus 2. Now I need to switch my symbol, my inequality symbol, because I've divided by a negative. So less than or equal to y. Now, the first time you glance at those, you would say, well, they're almost the same, but one has the wrong sign. The inequality symbols are different. Well, not really. Both sides have switched. So if you solve for y and it was on the right, just rewrite it where everything changes sides. Bring the y over here, 5/8 x plus 2. But in order to do that, you need to reverse your inequality. So we do end up with exactly the same inequality when it's all said and done. All right, so I don't have any really large numbers. I am going to be able to count by ones on my scale here. So in this blue one, the y-intercept is 2, and the rise over run, the slope is 5/4. So rise 1, 2, 3, 4, 5, 1, 2, 3, 4. It will be a dashed line because it's just a simple less than. There's no or equal to. Let's find our dashed line tool. And let's go ahead and extend that through the graph. Okay. And then for shading, it is less than 5/4, so that tells me I should shade everything under that line. All right, for the pink one, we have y greater than or equal to 5/8 plus 2. It also has a y-intercept of 2. Now the rise over run is 5/8, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. This one will be a solid line since it has or equal to. So, solid line. And our shading will be above because that's greater. So above this pink line. So where did we shade both colors? It's in this triangular section in the first quadrant here. That is the solution to the system as a whole. Okay, number 4. I will, well, let's do the intercept method again. These aren't exactly in standard form. If I want to rewrite this one as -x plus 2y greater than or equal to -10 so that it's actually in standard form, I can do that. So this one would have x-intercepts and y-intercepts. Let's test them out. For x-intercept, I am ignoring the y term, and I have 5x is 5. Divide both sides by 5, x-intercept is 1. Y-intercept, ignore the x term, so negative y is 5. Divide both sides by -1, you are left with -5 for a y-intercept. This one we'll do in pink. So for x-intercept, I'm ignoring the y term. I have -x is -10. Divide by -1, that gives me 10 for an intercept. For y-intercept, ignoring the x's, I have 2y is -10. Divide by 2, my y-intercept is also -5. Okay. So I will be able to 2, 4, 6, 8, yes, I can count by ones. So this blue line would have an x-intercept of 1, a y-intercept of -5, 2, 4, 5. It will be a solid line since it is greater than or equal to. So like that, I will shade, well, I don't have the shading yet. So since we are using this intercept method, I need to do the checkpoint. So I'm going to test 0, 0 because it's not on the line to see which way to shade. So 5 times 0 minus 0 is greater than or equal to 5. 5 times 0 is 0 minus 0. So 0 greater than or equal to 5. That's false. So I cannot shade the 0, 0 for this blue line. That means I need to shade everything below the line. All right, for the pink one, I have an x-intercept of 10, and a y-intercept of -5. This one is a solid line also because it's or equal to. So solid line. And I need to, again, use a test point. I can use 0, 0 for this one also. So I'm going to put it into the original inequality. I could have also used the one that I circled up there in pink. 2 times 0 minus 0 is greater than or equal to -10. 0 minus 0, which is 0, greater than or equal to -10 is true. So this time I will shade everything on the side containing the 0, 0, so everything above the pink line. So again, everything in blue works in the top inequality, everything in pink works in the bottom one. We are actually interested in what works for the system, for both, and that is where we overlapped the part that became a sort of purple color here. I'll make it look more purple, but this section in the upper right. Any point in this purple section would work for both inequalities. Okay, now number 5 has 3 inequalities. You don't do anything differently for this. You just repeat that same process 3 times instead of 2. And when you shade, you would be looking for where all 3 colors intersected. Okay. Now these are all in standard form, so I'm going to go ahead and use the intercept method. So in this top one, if I cover up the y terms, I have 5x is -25, giving me an x-intercept of -5. If I cover up the x's, divide both sides by 2, I get -12.5. For the second one, cover up the y terms, 17 divided by 3. Now that's 17/3. You probably don't like that, and it would be hard to locate on a graph. We do not, however, want to make it a decimal. Do not make it a decimal. So we can divide and think of it like a mixed number. 17 divided by 3 is 5 2/3. That would be easy for you to graph. The y-intercept, we cover up the x's, divide 17 by -2, we have -8.5. And let's see what other color we can throw in here, maybe an orange. So when we cover the y's and we're left with x is 27, and cover the x's, 27 divided by -6 is -4.5. So I will need to change my scale. The largest value here I have is 27. So I'll make my scale 3s. All right. I might even want to number some of that to help myself. 3, 6, 9. This first one that we have in blue, our x-intercept's -5. Our y-intercept's -12.5. It is a solid line because it's or equal to. Whoops. Okay. And again, since we use this intercept method, we are going to have to choose a test point. So we can test 0, 0. So that's 5 times 0 plus 2 times 0 greater than or equal to -25. Well, 0 plus 0 is greater than or equal to -25 because 0 plus 0 is 0. So that is true. 0, 0 works. So it needs to be shaded above the blue line. So everything above the blue line. Pink. 5 2/3 for an x-intercept, so almost to 6. Y-intercept -8.5 is almost to -9. That one also a solid line because it's less than or equal to. If we use 0, 0 again for our test point, testing 0, 0, we would have 3 times 0 minus 2 times 0 is less than or equal to 17. 0 minus 0 less than or equal to 17. Yes, that is true. So 0, 0 should be shaded for this one too. In this case, it means everything above the pink line. Okay. The last one that I have in orange here has an x-intercept of 27 and a y-intercept of negative 4.5. That one is also a solid line. It's greater than or equal to. So, and this one, I can also use 0, 0 as my test point. So, testing 0, 0. Zero minus 6 times 0 greater than or equal to 27. We end up with 0 greater than or equal to 27. Well, this one doesn't work. This one's false. So what that tells me is I can't have 0, 0 shaded orange. I'm going to have to shade it underneath the orange line. Where did I shade all 3 colors? That would actually be the solution to this system. Well, it's just this little triangle here in the center. That's the only place where all 3 colors overlapped. So if you wanted a point that you could substitute into all 3 of those, it would have to come from this small little triangular region. All right, we get to try that again. We have another one with 3 inequalities. They also are in standard form. So I'm going to go ahead and use this intercept method again. So x-intercept is when we ignore the y's. So 21 divided by 2 is 10.5. Y-intercepts is when we ignore the x's. So 21 divided by negative 3 is negative 7. Second one, ignoring the y's, x is 6. Ignoring the x's, 6 divided by 4 is 1.5. And the bottom one here, for x-intercept, ignore the y's. We have negative 4 divided by 3, so negative 4/3. If you'll have trouble with that on the graph, you can make it negative 1 1/3. Please do not use a decimal. That one would have, that's a repeating decimal. We do not round. The y-intercept is when I ignore the x's, so y is negative 4. All right, so I am going to need to slightly change my scale, or I can just maybe have a point go, that 10.5, I'll just go ahead and put that slightly off. This is 2, 4, 6, 8, 10. A half would be like right there. I will cheat a little bit. So 2, 4, 6, and there's 7. This would be a solid line in blue. And I'll need to do the test point. Test 0, 0. So 2 times 0 minus 3 times 0 less than or equal to 21. 0 less than or equal to 21 is true. So we would want to shade this one above the line. The pink one, x-intercept is 6, so 2, 4, 6. Y-intercept 1.5. Another solid line. And we'll try our test point, which I can still use 0, 0, yes. So 0 plus 4 times 0 is less than or equal to 6. 0 plus 0 less than or equal to 6, and that is true. That tells me I should shade everything below the pink line because I want the 0, 0 to be shaded. All right, and the orange one. We have an x-intercept of -1 1/3 and a y-intercept of -4. Once again, solid line. So let me get that extended. And we'll try the point 0, 0 again. So that's 3 times 0 plus 0 greater than or equal to -4. 0 greater than or equal to -4 is also true. So I want 0, 0 to be shaded orange also. So that means this side of the orange line. Once all three shaded regions are on here, we're looking for where did they overlap? Where did I shade blue, pink, and orange? And again, there's a triangular region on the inside here. So I would want to shade as either another color or darker, somehow indicate this is actually my solution. Okay. Anything in that triangular region would work in all three. And last one, we have a graph already completed, and we want to come up with the inequalities, the system of inequalities that would result in that graph. So first, ask yourself, how many inequalities will it be? Is it 3 like the last two problems we did? Well, there's only 2 lines on the graph, 2 different colors of shading, so there will only be 2 inequalities, a blue one and a red one. So let's look at that blue one first. In order to write the inequality, I first have to pick 2 points off of that graph. So I can see here 0, 7 is a point, and I can see this point is 3, 4. It doesn't matter which 2 points you chose, just 2 points. Okay? To identify the slope of that line, I would do rise 1, 2, 3, run 1, 2, 3 to the left. So my rise over run is up 3, left 3. Well, that simplifies to -1. The y-intercept is this point 0, 7. So I know that that, in equation form, is y equals -1x plus 7. However, I'm not writing an equation. I want an inequality. Everything below that line is shaded. So that inequality is y is less than -1x plus 7. And my only decision left, my last thing is, do I want to include the or equal to under there? Since that line is solid, that means all the points in that line count. Yes, I do want that to be less than or equal to. All right. Let's do that one more time with the red line. The red one, I can see one point here is 9, 0. And another point I'm identifying here on the y-intercept is 0, 3. So our slope, our rise over run on that red one is I rise 1, 2, 3, and then I go left 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's -1/3. The y-intercept is the point 0, 3. So the equation of the line is y equals -1/3 x plus 3. To write it as an inequality here, it's y, well, the shading is underneath the line, so less than -1/3 x plus 3. And lastly, again, ask yourself, is the line solid or dashed? And it is solid, so we include or equal to. So this is our system of inequalities.